Hello everyone, welcome to my first video. In this one I'm going to demonstrate how we can connect a Spring Boot application to an Elasticsearch instance. So Elasticsearch is a NoSQL database, and it's a very popular search engine that is commonly used for log analytics and text-based search, and there are a lot of other use cases. I would recommend to have a basic idea of what it is and how it is being used in modern applications. You can download Elasticsearch by going to the official website. If you want to download, you can type Elasticsearch, and I would recommend to download 7.17 because that is the latest version that is the Spring Boot is supporting as of now. So you can go to this link, and depending on your operating system you can select your files. So I have a Linux system that is 64, so I'm downloading this one. So once it is downloaded, you can go to the you can browse to your zip folder and you can extract it. And you can open this folder, and you can see the bin folder here. So there is a command Elasticsearch. So go to the terminal and just run Elasticsearch, and this should bring up the Elasticsearch instance. It will take some time. Let it come up. Okay, to make sure if it is running or not, you can do one thing. You can go to localhost 9200, and this should give you an output like this. So this means your Elasticsearch is running on the port number 9200, and this is your REST API URL, and yeah, this will be used in the application. Now let's go to start.spring to download a fresh Spring Boot project. So you can leave as it is, like Maven, Java and 2.7.3. Then you can give any name. I'm going to give step, and then I'll give something Elasticsearch Spring Boot demo. You can keep any description, and the packaging is jar. You can keep your Java version. Then you can add the dependencies. For now I will add the Spring Web and Spring Data Elastic. So this should download all the dependencies which I need to make a connection to the Elasticsearch. Now click on generate and then wait for it to be downloaded. Once the project is downloaded, you can import it into your favorite IDE. Let's extract the file. I will open my favorite IDE, that is IntelliJ. And let it download all the dependencies and files it needs, and let's wait for it to be completed. Okay, now the project is ready, and we will use a bottom-up strategy here. First we will create a configuration class for Elasticsearch, and then we will need a Pojo class. Then we will create the repository interface for connecting our application to the Elastic, and then we will go to the service class, and then at the last we can write our controller classes for the APIs. Okay, let's create our configuration class now in the package config. We'll create a class here, Elasticsearch config. We will extend this class with abstract Elasticsearch configuration, and it has a method called Elasticsearch client that has to be overrated. Okay, now inside this function we need one more thing. We need a client configuration. We'll use the help of this the builder method. You can specify the URL here, and then you can use build to build this class, and then we need a REST high level client, right? So we'll use the REST client class. Notice the spelling. We are going to use REST clients dot create. You can pass the configuration, and then you can call the method REST. This will return a REST high level client. Okay, so return. You can specify the URL. So localhost 9200 is the port number that the Elasticsearch is running. Okay, and also this thing is returning a REST high level client or an object of REST high level client. So we need to register this in the bean factory. So for that we will use the annotation bean, and since we are using at bean, we also have to mention annotate with the class with the configuration to tell the Spring framework that this particular class has a bean definition. Okay, now we have the configuration class. Now let's move to the repository interface. Before we create the repository class, let's go ahead and create one a model class, which I will keep it in the package model. We'll name this as Shinobi model. This will have 3 fields. Okay, now we need some getters and setters for this. So let's go ahead and generate those. We'll select all these 3 and press OK. Now we have the getters and setters method and the 3 fields. Now we need one more thing, private string ID also, so that it can be identified, and we'll use the annotation ID. So we have the Pojo class. Now only difference between the normal JPA repository, we have to use the annotation at document here instead of at entity, and we'll provide one index name that will be the index name of you can do one thing, just go through the document of Elasticsearch and understand and do a comparison between this Elasticsearch and the normal relational database system. You will understand what is index and how it is related. So we have the Pojo class. You have to use that ID, and it's not mandatory, and this is mandatory at document. You have to use in order to represent our model, and it can be used to process the data in the Elasticsearch. Next, let's create our repository class now. So I will create one more package for repository. So it's not going to be a class, it's an interface. I will name it as Shinobi repository, and we'll extend this with Elasticsearch repository, and we'll use Shinobi model and the data type of the ID, that is string, and we can annotate it with repository. Okay, now we have our repository, the Shinobi repository and the model class. Next is the service class. Let's create one more package, service, and inside this we'll create a class called Shinobi service, and we need some functions to get the Shinobi and to save it. Okay, we're going to pass ID into this function, and then we need the repository to be auto-wide. Okay, we can return Shinobi dot find by ID, and we can pass the ID. Okay, and so it's going to return an optional, so we can use or else, and if it is not there, you can use null. And we need one more function, public Shinobi. Let's not use just one, let's use a list of Shinobi. This will take a list of Shinobi model. You can use save all method, pass the list. Okay, again this is going to return an iterable, so yeah, we can cast it into list Shinobi. So we have our service class now, and one more thing, we have to annotate it with service so that it can be auto-wide in the controller class. Now we need a controller class also to write our APIs. Now I will create one more package, controller. Inside the controller, we'll create a new class called Shinobi controller. So this is going to be a REST API controller, so I will annotate it with REST controller, and then we will use get mapping. Can give it a Shinobi. This API is going to fetch a document from the index with the ID which we pass through the either through request param, or we can pass it as a path variable. So this is going to return a Shinobi model. So it is going to take an ID. Now, like I said, it can either be request param or path. I will go with the path variable. We'll use ID. Here we can provide the ID like this. Okay, now we need to auto-wide the service class. So we can use the function get Shinobi and can pass the ID. Okay, now we have the function to get a Shinobi. Now we need one more function to add Shinobi. So I will use post mapping. I will use the same API Shinobi, and this is going to return a list of Shinobi models. And also this is going to accept a list of Shinobi model. and this list will be part of the request body, so I will have to use at request body annotation here, and then I can call the service class to add Shinobis by passing the list. Okay, now we are ready with the controller. Now we can test our application. Before I start this application, let me show you one thing. So this is the Elasticsearch URL. It is running on 9200. So I'll do one thing. I will just try to hit this. We'll try to hit that index name, Shinobi. So look at this response. So it says index not found. So when we start this application, you can run this function. Now when we try to hit this URL, as you can see, it is returning a different response. Now it means that the Shinobi index has been created. So I'll tell you why that happened, and you can see in the model, right? In Shinobi model we use a document annotation. Here you can see so by default it is true, like it is going to create the index if it is not there. Okay, now our index has been created. Now I will do one thing. I will use this this particular post API to add this to Shinobis. Okay, there is no error. We got 200 as the response status code, and let's use this URL once again with a search command. So this is REST API, Elasticsearch API for searching the index. As you can see, these two Shinobis has been added. Now it has its own ID, so I can use one of the ID and make a get call. Okay, now we got one document from the index with this ID. It is working as expected, and this is all you have to do actually. You can create a configuration class where you can extend abstract Elasticsearch configuration, and then you can override the function Elasticsearch client. And since it is a bean, you have to use at bean annotation to configure it in the bean factory. And then we created a model. We annotated with a document, and then we created a Shinobi interface, a repository, and then the service class and the controller. So if you have any question, or if you're stuck anywhere, then let me know in the comments. Thank you.